Anti-pattern is everywhere. It is important to recognize them and avoid them. Hi there, how are you doing today? Let's talk about anti-patterns in dependency injection. This is the fourth topic around dependency injections. Check out the other videos if you're interested in. And let's begin. The first anti-pattern that I want to mention here is to register a singleton service, which is not created by the service container. An example of the code is like this one on line 40. There's a significant difference in between line 40 and line 38-39. On line 38, at the time of registration, the service container is given the service type and the implementation type, and the console outputter will be created when injection happens by the service container. It is similar for line 39 that we have the service type and a implementation factory, so that when outputter is needed, the implementation factory will be called by the service container to create the instance. However, the code on line 40 is anti-pattern. The instance of console outputter is created by the developer here, not by the service container. If the service container is not responsible for creating the service, it is not responsible for disposing the service. So it becomes a responsibility for the developer to dispose it. Let's see it in an example. Okay. Let's comment out these two lines first to have these one by one. Let's take a look at the console outputter. This is about dispose, so I make the outputter disposable. To see the dispose, I'm going to write a message when the dispose is called. Okay, coming back to console outputter, let's use the first way to register the outputter. Let me run it. Making some space. So I'll split the console and I can curl into it on the right hand side. Okay, don't worry about the output of hello yet, but if I Control C, you can see outputter dispose is called. This is the pattern 1. Now, if we use the second method, this one gives the implementation factory, and we'll see how it goes. Running, let me do the curl, same thing. Now the output dispose is called automatically here. Okay, let me do the third one. And Control C, and there is no dispose being called automatically. So this is the anti-pattern number 1. If we feed the service container existing instance, it bypasses the logic to let the service container create the instance, and the service container is not going to dispose the service automatically for you. So don't do that. Let the service container do the job and manage the lifetime for you. The second anti-pattern is the captive dependency. What does this mean is when you have a smaller lifetime services and they are made dependency of longer lifetime services, that longer time service will capture the lifetime for the smaller ones. For example, the outputter and serializer are registered as scoped services. The doc report, on the other hand, is registered as a singleton. Since the doc report have dependencies on both outputter and the serializer, it will capture the lifetime of the outputter and serializer to become a singleton. And that is an anti-pattern. Actually, if you run the code directly, it will throw exception because of this pattern. It is because by default, in the development environment, there is a scope validation that is put there by default. I'll show you where that is in program.cs. Here, if you read the comment of create default builder carefully, there is a text saying enable scope validation on dependency injection container when the environment is development. Okay. To disable that, let's add this so that we can see what will look like when this happens. To observe the symptom, I updated the console outputter a little bit to give it an ID, this will become like one ID for one instance. And the instance ID will be output when writeLine is called. Now let me go ahead and update the weather forecast controller so that it will inject the doc report. At this moment, I assume you are very familiar with what I'm doing here to inject the doc report. Otherwise, please review the previous sessions in this series. Before we run the code, let's review the expectation again on the service registration. The I-outputter is scoped service, as well as the I-serializer, and the doc report is registered as a singleton. So the expectation is for every call to weather forecast, the I-outputter will be injected new, and the doc report will always be the same instance. Now let's run it. On the first call, there is an ID output of 34DA blah blah blah. Notice this is the ID for the I-outputter, and it's supposed to be changed every single request. Now let's call it again. And no, the ID is still 34 blah 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 for the outputter. This is what the anti-pattern leads to. The I-outputter is registered as a scoped service, but it has been captured by a longer lifetime service, which is the doc report in this case. Imagine that I-outputter requires a critical resource, like a database connection or something that needs to be released as soon as possible, and once it's captured by the singleton of the doc report, it will always holding the resource, and that's going to cause us a lot of headache. And that is the anti-pattern of captive dependency. To address that, one compromise is just to register the doc report as a scoped service as well. The third anti-pattern is to use asynchronous operations in the implementation factory. To show that, I create a waitForLet async method, which takes in a service provider, waited for 1 second before returning the I-serializer. Doc report is going to rely on the I-serializer, go through that step before it returns the doc report. Oh, by the way, if you're familiar with the asynchronous operations in C#, you'll see the line 53 by itself uses the sync over async. It is something calling for trouble by itself. This pattern is going to lead to a hung. To reveal it, I put two messages, one in front of the asynchronous operation, the other after it. Let's run it and see what happens. Now let me curl into the weather forecast, which has a dependency on the doc report. Now we see the before async operation as it's outputted on line 52, but we don't see the post async operation message because it hangs on line 53. And that is the result of the anti-pattern. Let's do a quick recap. We talked about 3 anti-patterns today. The first one, we created the service by ourselves instead of rely on the service container. That leads to the service container do not dispose the service automatically. The second one, we have a longer lifetime service capture the shorter lifetime services. It's called the captive dependency, and that leads to the resource being disposed later than we expected. The third anti-pattern is to use asynchronous operations in the implementation factory. That leads to a hung when the implementation factory is invoked. Alright, that's it for today. I wish you enjoyed it. Let me know by clicking the like button below. Subscribe so you don't miss the next one. Let's keep improving the design of the code. I'll see you in the next one. Until then, take care.